Hello everybody, good morning. Are we ready to get started? Okay, today I'd like to talk about artificial intelligence, or AI. First, I'd like to begin by defining AI and looking at some of the different approaches to AI. Then we'll discuss some of the challenges faced by scientists working in this field. We'll finish up by looking at some of the accomplishments of AI and what scientists hope to achieve in the future. Okay, so first, what exactly is artificial intelligence? Well, it's a relatively new science. Researchers only began to work on intelligent machines back in the 1940s and 50s. John McCarthy, a computer scientist at Stanford University, defines AI this way: as the science and engineering of making intelligent machines, especially intelligent computer programs. So let's use this definition and go a bit further with it. Intelligent machines. Before we can make an intelligent machine, we first need to decide what we mean by intelligent, right? And then how we go about programming that into a machine. Well, so far there have been two main approaches to doing this. One approach aims to create machines that can think or act rationally, though not necessarily just like a human. For example, some scientists have worked on creating machines that do things, like perform physical tasks, like, for example, a robotic vacuum cleaner, but they do them in a non-human way. Now, the second approach aims to come up with machines that can actually think or act like humans. They actually simulate human thinking or do things that require human-like intelligence, such as carrying on conversations, just like a real person would. Okay? Everyone with me so far? Okay, so let's say we want to build a human-like machine. How can we know if we're successful? In other words, how do we figure out if a machine actually can think or act like a person? Well, in 1950, a scientist named Alan Turing developed a test to answer this question. The Turing test is still used today to measure whether a machine has human-like intelligence. Okay, there, in this diagram, you see a human judge who sits in a room with a computer. The judge types messages and carries on two conversations, one with the computer and one with another person. Now both reply, and the judge tries to decide which is the person and which is the machine based on their answers, their conversation. So, if the computer can fool the human judge, if the judge thinks the computer is human, it passes the test. Now, Turing guessed that by the year 2000, a computer would be able to pass the test, but he was wrong. To this day, no computer has been able to pass the Turing test. Okay, so why haven't scientists been able to develop a machine that is human-like enough to pass the Turing test? The main reason is that human beings are very complex, very complicated. And human thinking requires a lot of different skills that you just can't program into a computer. Okay? Let's look at some of these. First of all, a machine with human-like intelligence would need to have what we call natural language processing skills. That is, the ability to communicate naturally in a language. But to do this well, a machine needs to have the human ability to use context to understand the meaning of words and sentences. Now, so far, no machine can do that. So, Next, it would need to possess knowledge representation. In other words, the ability to store what it knows or hears, just like our brain stores information. Okay, third, it would need to be able to reason like a human being, to use the stored information to think and come up with the answers, like a person would, which is, surprisingly difficult. Now, this is because even though computers are great at solving many problems very quickly and accurately, it's very hard to design one that has the same kind of common sense that humans possess. Just the ability to figure out the best thing to do in a situation based on experience and intuition and on feeling. Now, we have it, computers don't. Finally, to pass the Turing test, a computer would have to be able to learn so that it could adapt to new situations based on lessons learned in the past. Now, these skills I just showed you are only the ones needed to pass the basic Turing test, where there is no physical interaction between the computer and the judge. An even more challenging test is the total Turing test. Now, this requires both a visual and physical interface. So it's not just typed messages back and forth. Now, the total Turing test is done with a video monitor. So the judge can test the computer's ability to perceive visual input, to see something and respond to it. Now, there's also a hatch or a little door where the judge can pass objects to test the computer's physical abilities. So, to pass this test, a computer would have to possess vision, and it would have to be robotic so that it could handle objects and move around, which is much more difficult. So, we all know no machine can accomplish all of these things. Well, not yet anyway. So, researchers have focused much of their attention on developing machines that are good at just performing specific tasks, but aren't necessarily human-like. Now, there are several areas in which AI has been successful in doing this. Robots, for example. Robots can do lots of physical tasks that are dangerous or difficult for humans to perform, such as cleaning up nuclear waste. The military uses smart machines, types of robots, really, to help on battlefields and in unmanned aircraft. What's really exciting is that robots are now being used in hospitals, like in places where there isn't a human doctor, like in an area that's difficult to reach, far away from a city, Now, I have a picture here I found that I thought you'd like to see. Yes, here's an example of a robo-doc. See him talking to the patient. Now, some robots even perform surgical procedures now. What are some other applications of AI today? Well, in addition to robotics, AI can play games, like programs that can play chess. People are using more and more AI for natural language processing needs, like when your computer or cell phone is programmed to understand and respond to your voice, to specific commands. Every day, scientists are coming up with machines that look, sound, think, and behave more and more like people. As a result, some scientists are confident that it won't be long before we have human-like machines. But the other big question that brings up is whether or not we even should develop intelligent machines. But, you know, we don't have time for that today. I'll end here for now. More about that next week. So see you then.